All right, so right now we're going to start talking about titrations and how to find the equivalence point and mathematically what that looks like when we don't have the graph or we have to generate the graph from data. And so for this one, we have the titration of zero point 0.1 liter of 0 0.1 molar acetic acid with 0 0.1 molar sodium hydroxide. Normally, the first question we would ask is if we're titrating the two is do we have a reaction? And so we look at what do we have? We have a strong base and a weak acid. And so yes, we have a reaction, and I've asked you to write the net ionic for that. So I would like for you to pause the video, go write that reaction now. If you have to go back to your chapter 4 material to figure out how to do it, I would absolutely do that, and then come back to this video. So continuing on with writing that reaction for a net ionic, you'll end up with this as your net ionic. And again, these would be aqueous. And this is what it looks like. So notice that I've kept my acetate intact, because that lets people know that that is a weak acid. So if a scientist were to read that, they would say, oh, it only partially disassociates. So some of it disassociates and some of it stays together as acetic acid. And then you can see the rest of these phase labels. So that's what your net ionic equation would look like. That's what the reaction is. The next part is we've got to figure out what's the pH at equivalence. So let's put a second thing. How do we get to pH at equivalence point? Well, we know from the previous video that ultimately the pH at equivalence of a weak acid strong base should be greater than 7. So let's see what we find out. Well, the first question we should ask outside of the reaction is, what does equivalence actually mean? So when we talk equivalence point, we're really referring to the fact that the moles of the acid equal the moles of the base. And can we find out how many moles of acetic acid or sodium hydroxide we have? If you look at the numbers, we absolutely can. We have 0.1 liter of 0.1 molar acetic acid. So let's see what we can do with that. So we're just going to find out what are the moles that we even have. So we have 0.1. I'm just going to drop some of the sig figs for space. And we're going to multiply that by the volume in order to get the number of moles. Well, if we're at equivalence and we want to find out what the pH is at equivalence, then truth be told, what we really have is the moles acid equals moles of base. So I already know what the moles of base will be, 0.010. Because again, if we're at equivalence, they must be equal. So I'm going to write a note at equivalence. Then my question is, now that we're at equivalence, to figure out what kind of pH we have, and we know we have a reaction, so we've now got 0.1 mole in there, 0.01 mole of acetic acid, we've delivered now 0.01 moles of hydroxide. What do we now have? We have a limiting reactant situation. So we have minus 0.010 and minus 0.001, and over here where we have 0, we don't have to really deal with much as water, but we have 0 in terms of the, get rid of some of this so you can see it, we have 0 of the acetate, because we don't have any acetate in the solution to begin with. So now we've delivered 0.01 of the hydroxide in there, and that means for every 0.01 that we've consumed, we produce, let me get back to my red, so that way they'll all be the same. We've produced 0.010 moles of acetate. And so when we look at this, we have no acetic acid and no hydroxide at equivalence. That's the case because we have the same number of moles of each. And then what we do have, though, which is interesting, is we have 0.010 moles of acetate. Well, that's certainly not neutral. If we only had water, the pH would be 7, but we don't have just water, so we've got to deal with this. So then our question goes back to, what kind of solution do we have? So you can see there's somewhat of a pattern in some of this. What kind of solution do we have? And so, do we have a buffer? No. Do we have a Ka? That means we'd have a weak acid in water. Nope. Do we have a Kb? So if we had a Kb, that means we have a weak base. In water. So we have a weak base in water. So that means we have acetate plus water, and that's our Kb. So double arrow, and we have then acetic acid on the other side plus hydroxide. So we're going back to that chapter 16 material where we talked about acid disassociating in water and base disassociating in water and so forth. So now we have an equilibrium. We have an ice chart. And so when we have this ice chart, I can start with my acetate. I have 0.010 moles. I don't have to deal with water, and I have no acetic or hydroxide. And so the next thing, though, remember, if you're in an ice chart, we have to have concentration. So we need to divide by total volume here. So we've got to figure out what the total volume is now in that flask to which we delivered 0.01 moles of hydroxide. We know at least part of the volume is from the acetic acid that's there, so we already have 0.1 liter, but we now also need to know how much volume did we add in order to get that 0.1 mole of hydroxide. So I put plus volume of hydroxide. So to figure out the volume of that hydroxide, I need to go back to that equivalent information. So I'm going to come over here and get rid of some of this top information so we can do that, since you will already have this on the video or in your notes. And so now to find out what that is, I'll come back to blue and I'll have 0.010 moles. Now notice, we know a couple things. We have the number of moles. We want to know how much volume was delivered. But remember, we have an equation called molarity, and that molarity is equal to moles over volume. Do we have the moles? Yes. Are we looking for volume? Absolutely. And then we have our molarity. And so our molarity that we've been given was, according to the problem, 0.1 molar. So I can solve and find out that X ends up being 0.10 liters as well. So that's how much it took to deliver 0.01 moles of hydroxide. So then I can come down here and my total volume now is 0.10 from the acid that's there plus 0.10 from the hydroxide. And that's going to give me my new concentration to plug in here. Now, I'm going to let you all continue solving that problem because it becomes an ice chart problem, and you can find the pH associated with that. And your pH, remember, should be greater than 7. And the question is, well, why? The reason is because after we do this math up here, this also goes to 0. So we have no acetic acid and no hydroxide. And water, we know if we had only water, the pH would be 7. But here we have this conjugate base. So that base, because it's there, creates a basic pH and hence makes the pH greater than 7 at the equivalence point. Now the exact pH you can find from this ice information once you solve for X. Find the pOH and then find the pH from that. Also, what I want you to do at this point is I've posted case studies online. There's a key, but don't look at the key first. Do your case study first. Work through those piece by piece, and those will give you extra practice, and we will talk about those on the online session in class.